For example, let's see the sum. As I said earlier, G3 has sum of G3. It has the sum to infinity, and it also have geometric mean. So now let's see the sum. Sum of geometric progression. The sum which is given as Sn is now equal to A into R power n minus 1 over R minus 1. But it is categorized into two. That is, the formula is given into two. Is like in this case, that is in case of R is greater than 1, but R is not equal to 1. If R is equal to 1, here will be undefined, and undefined is not, we don't have solution for undefined. The second one says Sn is equal to A into 1 minus R power n over 1 minus R. You see the difference? R comes first here, while here 1 comes first. So in this case, is R is less than 1. Also, R is not equal to 1. So these are the two formulas to find the sum of geometric progression. This one is where R is greater than 1. When your common ratio is above 1, that is 2, 3, 4, 5, then you use this first formula. While in the second formula, if your R is less than 1, that is less than 1, 0.5 minus 3 minus 4, then we use this formula. Now let's see one example. Find the sum of the first fifth term of the GFP. So 1 over 2, 1 over 4, 1 over 8. Assuming we are given this these terms, we are to find the sum of the first fifth term. First thing, for you to simplify your work, just collect the data. Our A is the first term, which is given as 1. Then R is what? The common ratio, which is 1 over 2 divided by 1, and is the same thing as 1 over 2. Then the next one is what? Our N. N is the sum of the fifth term we asked to find, which is 5. So now before we write down our formula, we have to check for R. Is R less than or greater than 1? So in this case, look at our R. Our R is 1 over 2, and 1 over 2 is 0.5. So therefore, our R is less than 1. Since R is less than 1, we are using the second formula, which says A into 1 minus R power n over 1 minus R. So, and we are going to have S of sum of 5 is now equal to A is 1 into 1 minus R. R is 1 over 2 all into 5 divided by 1 minus R, and R is 1 over 2. So we just simplify. You're going to have here 1 multiplied by anything is just the same thing. So our S5 is equal to open bracket 1 minus, look at it, just take the power. 1 power 5 here is 1 divided by 2 power 5 here is 32. Now here 1 minus 1 over 2 is just 1 over 2. Next thing, just to what? Let's make it and find the LCM of the top. The LCM is 32. We're going to have here 32 minus 1, all divided by 1 over 2. So 32 minus 1 is 31 divided by 32. Let me say divided by 1 over 2. It's the same thing, this one divided by 1 over 2. Now let's take the reciprocal. The reciprocal says what? 332 here. If you are to take a reciprocal of rational numbers, just the division will turn to multiplication, then the numerator will become the denominator and the denominator will become the numerator like this. We're going to have 2 over 1. So having this, I can remove 2 here. If I remove 2 in 32, I am going to have 16. So we are going to have here 2, here 1, 2, here 16. We're going to have 31 over 16. So this 31 over 16 is the sum of the fifth term of this. Okay? Now the next thing is, let's see the geometric, what geometric mean. If you can recall, in arithmetic progression, it also have arithmetic mean. So also, geometric mean has its own geometric mean. Now geometric mean. Okay. Now let A, B, C be 3 consecutive terms in GP. Assuming this A, B, C are 3 consecutive terms in GP, this shows that if they are GP, it shows that the common ratio R is equal to B over A, or R is equal to C over A as usual. No, sorry, C over B, like this. B over A or C over B. Now let's take a look at it. R is this, and R is this, implies that B over A is equal to C over B. If I cross multiply, I'm going to have B times B, which is equals to A times C. B times B here is B squared, which is equals to AC. So this implies B is now equal to plus or minus AC. So this one here is the formula for finding the geometric mean of a given geometric series. This implies that whenever you are having 3 numbers, the middle number is the geometric mean. And this is how we found it. For instance, I may be given, let's say we have 2, 4, and 8. Assuming this is 2, 4, and 8, this is our A, B, and C. It shows that this B is what? This 4 is our B. And how do we find it? By taking the root of the product of the first and last number. The first and last number is 2 and 8. Now let's multiply them. 8. 2 times 8 here, we're going to have 16. And the root of 16 is 4. And you say the 4 is here. So this is how to find it. Now, let's take an example. Let's assume we are to find geometric mean between let's say 3 and 27. We have to find the geometric mean between 3 and 27. We just said the geometric mean is just equal to the numbers given, 3 multiplied by 27 in root. As usual from the formula, A times C, assuming this is A, this is C. We are to find the middle number. That is the geometric mean. So multiply this, we're going to have 81. So root of 81 is 9. So this is how to find geometric mean between 2 or more numbers. Let me just see one example, then we just carry on. Now, for instance, assuming we are given some numbers, that is example if 2x x plus or minus 1 and x plus 3 are jiffy, find the values of x. Now let's, for instance, we are given an example like this. Say these are 3 terms given, 2x, x minus 1 and x plus 3. And the main thing is that they say all these 3 terms are jiffy. If they are jiffy, find the possible values of x. Find the possible values of x. Whenever we are given a problem like this, you just put in your mind that this is geometric mean. How? Because it is 3 terms given, 2x, x minus 1 and x plus 3. From the previous explanation, you just assume that this is A, this is B, and this is C. Recall from the formula that B is equal to root of O. Let me use the second one. B squared is equal to AC. Just come here. What is your B? X minus 1. Square it is equal to A, which is 2xc. X plus 3. So having this, you just expand. Let's expand this bracket. We have x squared minus 2x plus 1 is equal to this one, 2x squared plus 6x. Now let's take a look at this. Going to result to quadratic equation. Let me take all this to here. Or let me just take it. We're going to have 2x squared, I started from here, plus 6x. When this one is returning, I'm going to have minus x squared. This one is coming, I will have plus 2x minus 1, all is equal to 0. So having this one, we just simplify. This is this. We're going to have x squared, that is 2x squared minus x squared. I'm going to have x squared. 6x plus 2x, going to have plus 8x. Then this one, minus 1 is equal to 0. If you take a look at this, it's now a quadratic equation. Now, you just solve the quadratic equation. After you solve, at last you are going to have 2 values of x, that is x1 and x2, to get the possible values of x. Hope is clear. So now the last item under geometric progression is what we call sum to infinity. Sum to infinity. The sum to infinity is given as Sn is equals to A over 1 minus R. The formula to find the sum to infinity of GFE. Let's see one example. Find up to infinity. Find the sum to infinity of the sequences. The sequences. The sequence. Let's give maybe I might give 1 over 2, 1 over 4, 1 over 8. So assuming these are the sequences and we are asked to find the sum to infinity. So to find sum to infinity, the only thing needed here is A and R. Solution. What is our A? Our A is 1 over 2. And R is 1 over 4 divided by 1 over 2, which is equals to 1 over 4 times 2 over 1, which is equals to 1 over 2 also. So the first term and the other are the same. But having that, just sum to infinity is equal to A, which is 1 over 2, divided by R, which is 1 over 2. 1 over 2 divided by 1 over 2 is equal to 1. So our sum to infinity here is 1. So with this, I fully hope that we are done with geometric progression.